Hi friends, before moving on to the construction procedure for arcs of circles method, we should be aware of few elements be- before starting of it. So once if it is an ellipse, we know that this is the major axis AB and it will be the minor axis CD, and there will be focal points for this F1 and F2. Now similarly, I said arcs of circle method will be useful for hyperbola also. Once this is the hyperbola and we know that this is the principal axis, and the focal points for this hyperbola is going to be present here as well as here F1 and F2, and wherever it intersects the axis, the curve conics or curve where it intersects the axis is considered as vertices V1, V2. But here we are considering these vertices as A comma B. So when we can able to apply this particular constant arcs of circles method, when we know the gap between the focal points F1 comma F2, we know the gap between the focal points F1, F2 and AB. What is this AB? So in case of ellipse, AB is termed as major axis, whereas in case of hyperbola, AB is termed as a transverse axis. Why it is called transverse axis, why AB is considered as a major axis, all this information was given in the conceptual videos. So just you go through them, you can able to get the word why they are coined for these two. Now, so whenever for an ellipse or hyperbola, if the gap between the focal points and vertices, normally in the ellipse also these two are two vertices V1, V2, but we are going to consider the gap between the vertices is major axis in case of ellipse, and in case of hyperbola it will be considered as transverse axis. Therefore AB and F1, F2 are given, we can able to apply arcs of circles method. So let us consider what is the procedure to be applied for arcs of circle method for ellipse as well as hyperbola. Both we will consider in this video. So first of all, we have to draw two lines which are perpendicular to each other. We have to draw two lines which are perpendicular to each other. So this is the horizontal line and this will be the vertical line. So two lines which are perpendicular to each other. Now for hyperbola also we'll try to know at the same instant. So arcs of circles method for hyperbola, these two we'll check it out. Here also the same scenario. We have to draw. Here two lines are not required. If you want we can able to do it, or we can able to draw only one. So this is going to be the horizontal line, and any one point if you want you can able to consider it, or otherwise any one point on it you may consider as the center O. We may consider the center as O. This is O for us. Now here also this is a O. Now let us consider F1, F2 is given and AB are given. So take half of the length of AB as radius, half of the length of AB as radius, O as center. Take half of the length of AB as radius, O as center. Draw the arcs on both the sides. Draw the arcs on both the sides of the horizontal line. This is one side, this will be another side. And assume them as A comma B. Assume them as A comma B. So there they are. Major axis points we will consider as AB. Now take half of the length of F1, F2 as radius. Half of the length. So normally F1, F2 length will be less in case of ellipse than vertices distance, that is AB distance. So we are going to consider this point. This is F1 and here we are going to get F2. So after getting F1, F2, same procedure we have to apply for hyperbola also. So we can able to consider the same for hyperbola. So what we are going to do here, F1, F2 will be more, AB will be less. So for example, O as center, we are going to draw the arcs with half of the length of AB as radius. With half of the length of AB as radius, we are going to draw it. So this is B and it is going to be A. A and B, we got it. And we will take half of the length of F1, F2 as radius. Half of the length of F1, F2 as radius. This is one arc and another side it is going to be like this. And we are going to mark them as, so vertex are assumed as AB. And focal points we are going to assume it as F1 and F2. Now after marking AB and F1, F2, in case of ellipse we will try to find CD also. How to get CD? That is very simple. We know the procedure that the length of OA means half of the major axis. OA is equal to CF1, therefore F1 as center. If we are going to draw the arc on the vertical line, we can able to get C as well as D. So for finding out CD, what we have to do? Take, I'm going to write here, then I will erase it. Take OA as radius, F1 as center, cut the arcs on vertical line, OA as radius, F1 as center, draw the arcs on vertical line. We will get C and D. We will get C as well as D. But this is minor axis is there for ellipse only. For hyperbola, no need to draw them. So after marking F1, F2 and AB, first step in this procedure, what we have to do? That is take, divide. This is important, my dear friends. Divide the axis, means AB from F1 onwards towards O. So remember one thing, mark 4 points. So why it is 4? No restriction. So for neat diagram, normally we will choose 4 points. So how the 4 points will be? Where I have to start? You have to start from F1. or F2, anything. Only one is sufficient. I will start the numbering from F1. I have to mark 4 points in between F1 and O. We have to move towards O. Towards O, we have to move for giving that numbering here. So here, first one you try to take as close as possible, very closer to F1. This is one. Second one, two, third, and fourth. If you observe my numbering, here the numbers are not uniformly, it is not equally spaced. First one is very close. Second one, the gap is increased. Third, the gap between 2 to 3 is greater than 1 to 2. Fourth, 3 4 gap is greater than 2 3. So just we are increasing the length. So if you do like that, you can able to get a neat curve. So what about for hyperbola? So hyperbola also, this procedure only is different and remaining are same. So here only the difference is we'll start giving the numbering from F1 only. We'll start giving the numbering from F1 only, but only the difference is we won't move towards the center, that is O. We'll take away from O. If O is on right side, we have to take the numbers on left side. So this is 1, 2, 3, 4. We are consider the points like this. I hope now it is clear to you. So first step is we have to mark AB and F1, F2 for both the cases. Then we have to mark 4 points on the axis by starting from F1 towards O. It is for ellipse, away other than O side for hyperbola. This point only is deferred for hyperbola and ellipse. Remaining steps will be the same. What it is, sir? First step is take A1 as radius. So take A1 as radius. So it is not appear clearly. So I am going to zoom this particular one to get the some more clarity. So take A1 as radius. So we are not going to get this one. So I will explain for A2. Then you apply the same procedure for A1. So due to the constraint of this particular page, we can't able to do it. Okay. So I will explain for A2. You may go ahead with A1 also. So first of all, take A2 as radius. Don't start with the 2 because there is a problem with the size of the compass. That's why I can't able to read. So what I have to do, take A2 as radius. What is the radius? A2 as radius. F1 as center. A2 as radius. F1 as center. F1 as center. Draw the arcs on both the sides of the axis AB. On both the sides of the axis AB. Here one arc and here it is going to be another arc. Now with the same length as radius, don't change the radius. Now you take F2 as center. F2 as center. Draw the arcs. Draw the arcs on both the sides of the line. Draw the arcs on both the sides. Similarly, here also we have to draw the arc. Now with one radius we have to mark 4 arcs. That is previously A1 as radius, F1 as center, draw 2 arcs on both the sides. F2 as center, draw the arcs. Next one is F2 as center, draw 2 arcs with the same A1. So next one. So but one is not possible, that's why I started with 2. A2 as radius, F1 as center, draw 2 arcs on both the sides. F2 as center, draw the 2 arcs. This is the step. So now you are considering, your consideration is point 2. So with A2 as radius, we drawn the arcs. Similarly, now we have to consider B2. What is the radius? Previously it is A2. Now we have to consider B2. We have to consider B2 as radius. B2 as radius. F2 as center. F2 as center. cut the arcs, because I am not aware where it exactly came. That's why in the first two arc I was not drawn properly. Normally you will get the point here. So for these you have to draw the arc here. So we got the point here. So I will try to get this particular point again, how it is. So if you draw the arc, you are going to get like this. Okay, similarly, so with F2 as center, B2 as radius, we draw the arc. Similarly, with F1 as center, with the same radius, we have to draw the arcs. You should draw the arcs here as well as here. But unfortunately it is not touching. Even you will also face the same problem, because we are not aware where exactly we are going to get these. So that's why I will again go ahead with A2. So those arcs are related to A2 radius. So I am going to take A2 as radius, and I am going to bring to F2 to cut the arcs. So we'll cut the arc here as well as at the bottom. Now we got we got 4 points for we got 4 points if you consider the point as 2. Similarly, the same procedure with 1 point I am going to get 4. Similarly, A3 as radius, if you do it, we will get 2 more points. So the same procedure we will apply here. What it is, we will take A1 as radius, we will draw the arcs A with F1, F2 as centers. With B1 as radius, F1, F2 as center, we will draw the arc. All of you observe. With A1 as radius, F1 as center, we will draw the arcs here on both sides. F2 as center, we will draw the arcs on both the sides. With B1 as radius, F1 as center, we will cut the arcs here. F2 as center, we will cut the arcs here. So for 2 I will explain here. So for that, what I have to do with next one is A2 as radius. What it is, A2 as radius, A2 as radius, F1 as center, draw the arcs, here. Same procedure whatever we applied for arcs of circles method there, here also the same method we are going to apply. So now F1 as center, A2 as radius, draw the arcs. Similarly, now A2 as radius, F2 as center, draw the arcs on both the sides of the axis. Okay, now so once if I take A2 as radius, we got 4 arcs. Next, what I have to do, B2 as radius. What is the radius we have to consider next? B2 as radius, F2 as center, cut the arcs on both the sides. Now F1 as center, cut the arcs here and there. Good, actually this is not touching, that's why I am taking again. What is the radius? A2. I have to take A2 as radius. A2 as radius. center will be F1. Center will be F1. Your arc is not touching. That's why I am going to draw it again. And here also the arc we are going to get it. Now after getting these, so we got the points for second element. We got the points for second. So if any excess curves are there, try to erase little bit. Don't draw excessively, erase little bit. Similarly, if you go ahead with the ellipse, I will explain again. With A1 as radius, we got two arcs here, here, here and here. Similarly, A3 as radius, F1 as center, we will draw the arcs. A4 as radius, F1 as center, we will draw the arcs on both the sides. F2 as center, we will draw the arcs on both the sides. Now B4 as radius, F1 as center, cut the arcs. F2 as center, cut the arcs. By joining all these points as a smooth curve, we are going to get the required ellipse. So by joining all these points as a smooth curve, so if you use the instruments properly, you can able to get the exact nature. Now here also, if you are going to take A3 as radius, F1 as center, draw the arc here and here. F2 as center, draw the arcs on both the sides. Now B3 as radius, F1 as center, cut the arcs. Same B3 as radius, F2 as center, cut the arcs. Now A4 as radius, F1 as center, draw the arc on both the sides. F2 as center, draw the arcs on both the sides. Now B4 as radius, F1 as center, cut it. Now B4 as radius, F2 as center, cut the arcs. So if you join all these points as a smooth curve by touching A, we are going to get the required hyperbola. We are going to get the required hyperbola. This is the hyperbola. Now, how to draw the tangent and normal to these curves? So we'll go ahead with the ellipse first, then we'll go ahead with the hyperbola. So for drawing a tangent and normal at any one point on the curve, let us consider at this point P, I have to draw the tangent and normal. So for that, we have to join PF1 and PF2. We have to join the lines. We have to join the points PF1 and PF2. PF1 and PF2. And bisect this particular angle P. So if we bisect the angle P, so how to bisect the angle? So for bisection, what is the procedure to be adopted? Take P as center, any length as radius, draw the arc on first line. With same radius, we have to draw the arc on the second, that is PF1 line, you have to cut the arc, and PF2 line, you have to draw the arc. Next, wherever it intersects, take that particular point as center. Take that particular point as center, draw the arcs here. Draw the arcs here. One arc is like this. And next, another point is this particular point as center. Cut the arc. This arc. Wherever they intersect each other, that is the angular bisector. So the angular bisection of the PF1 and PF2 will give the normal to the curve. Normal to the curve. So this is the normal to the ellipse. So how to get the normal to an ellipse? Consider any point on the curve. Join PF1 and PF2. PF1 and PF2. Now bisect the angle P, we will get the normal. Now if we draw the perpendicular line to the normal, we can able to get the tangent. If you draw a perpendicular line to the normal, we can able to get the tangent. So this is n dash, t, t dash. Similarly, same procedure will be applicable for this. So if I want to draw the tangent and normal at this point P, join Pf1 and Pf2, Pf1 and Pf2. Now we have to bisect this particular angle P. We have to bisect this particular angle P. We know how to bisect it. Take any length as radius. Take any length as radius. Take P as center, any length as radius. Draw the arcs on both the sides. Draw the arcs on both the sides. With those 2 points as centers. With those 2 points as centers. With the same length as radius. With wherever they touches it. Excuse me, there is a problem with the compass. Now take these 2 points as centers. Draw the arcs here. Draw the arc, one arc here. Another arc, because that arc is missed here. Now I will draw that one also. This some arc is here, this is missing. Now this particular point as a center, cut this arc. Now we can able to get the intersection point. If you join the intersection point with P and make it as a straight line, actually you will get it as a tangent. You will get this one as a tangent like this. So the bisection line, bisection at a bisection of angle for hyperbola will give the tangent. If you draw a perpendicular to it, you will get the normal. So in case of ellipse, bisection is the normal. In case of hyperbola, bisection of this angle is going to give the tangent. That is only the difference here. Now, so this is the way how we have to construct the ellipse by using arcs of circles method, and hyperbola by using arcs of circles method. So apart from tangent and normal, for especially for hyperbola, they may ask to construct the asymptotes to this particular curve. This is important. Asymptotes to the hyperbola. What is asymptotes? These are the tangents drawn to the curve at infinite point. How we have to do it? So this procedure I will explain carefully. Observe. Take O as center, O as center, OF1 or OF2, both the lengths are same. OF1 or OF2 as radius, OF1 or OF2 as radius. Draw the circle. Draw the circle. Now draw a vertical lines at A as well as at B. Draw the vertical lines at A as well as at B. So I hope it is clear to you, all of you, what we have to do. With O as center, OF1 or OF2 as radius, draw the circle. Then draw a perpendicular lines to the axis at A as well as B. Now wherever they meet the circle, assume the points as 1, 2, 3, 4. If you join 1, 3 and extend it, join 1, 3 and extend it, this is going to be the one asymptote. This is a one asymptote. While drawing the asymptote, you should be careful in one point. That is, this asymptote should cross the curve. You should not stop before the curve. It should cross the curve. Similarly, the second asymptote is this. This is the another asymptote. This is your curve. This is your curve. Now this is the another asymptote. So we have to draw both the asymptotes. So this is the way how we have to construct it. So quickly I am going to explain both. Just you have a look into it. Simultaneously I will explain. First step is take any one point as center, half of the length of AB as radius, draw the arcs on both the sides, will get AB here. Half of the F1, F2 as radius, draw the arcs, this is F1 and it is F2. Similarly for hyperbola, this is a horizontal line, center is O. Half of AB as radius, draw the arcs, we will get A comma B. Half of F1, F2 as radius, draw the arcs F1 and F2. Now mark the numbers from F1 onwards. First one is closed, second one numbering is goes on increasing. But here from F1 we should not give the points towards O, it should be away from O. This is 1, 2, 3, 4 like this. Now for in case of ellipse, what you have to do is draw a vertical line here. Take OA as radius, F1 as center, draw the arcs, we will get C comma D. This is only for ellipse we will consider. Now the first step, take A1 as a radius, F1 as center, draw two arcs, first arc, second arc, draw the arcs, Similarly, F2 as center, draw the arcs. So we are going to get like this here. Similarly, in this case also, A1 as radius, F1 as center, draw the arcs, F2 as center, draw the arcs. Now what I have to consider, take B1 as radius. Next one is B1 as radius, B1 as radius, F1 as center, cut these two arcs, F2 as center, cut these two arcs. Similarly here, B1 as radius, F1 as center, cut the arcs, F2 as center, cut the arcs. So with one reference point we got 4 points. Similarly, A2 as radius, draw the arcs, F1, F2 as centers. Here also A1 as A2 as radius, F1, F2 as center, draw the arcs. Now B2 as radius, F1, F2 as centers, cut the arcs. So very simple, like this we are going to get the 4 points here. So here also we are going to get 4. If you join all these points as a smooth curve, we are going to get the required ellipse. In this case we are going to get the required hyperbola. Now if you consider a point here, if you join PF1, PF2, if you bisect it, we are going to get the normal. Bisection in case of ellipse I am going to get the normal. In case of hyperbola, if it is P, join PF1, PF1, PF2, PF2, bisect it, we are going to get the tangent. So the bisection for in case of hyperbola will give the tangent. In case of ellipse, we are going to get the normal. If you draw a perpendicular to it, we are going to get the normal in case of ellipse. If you draw right here, we are going to get the sorry, in case of ellipse it is tangent, in case of hyperbola it is normal. This is the way how we have to construct an ellipse or hyperbola by using arcs of circles method. So in the coming videos we'll check it out oblong method of constructing an ellipse.